Our guest lecturer today is Ruja. He is here to share with you his bountiful knowledge about the sum and difference of cubes, which is like nothing. So, I mean, he's cute, but he doesn't do math. Welcome to the lesson. He'll just join us for the lesson. Maybe he'll learn something. Unit 4, Lesson 3, Part 1, Factoring Special Cases, Sum and Difference of Cubes. So welcome to the lesson. We'll go through this. This is an updated video from the one that I did about a year ago. Just kind of changing up the way that I'm presenting it, and I'll get a little bit more into that later on in the lesson. So this is what we call like a special case. So you've got like factoring, GCF factoring, which is pretty general. We've got factoring quadratics, which is a pretty general skill. We can use the area model or several other models to do that, including just guess and check, which is how I was taught. Then we get into some just kind of special cases. So we're going to cover sum and difference of cubes and then something called factoring by grouping, which are just other kinds of strategies that we can use to approach certain kinds of problems. So the first question we have here is, how do we recognize when we're looking at this particular special case, the sum and difference of cubes? So I wanted to start by breaking down the vocabulary. So when we're talking in class about the sum and difference of cubes, that we're all on the same page with what kind of a problem we're talking about. So first of all, sum, when we talk about the sum is the result of adding. Result of adding. And difference, we've already mentioned when we did difference of squares, is the result of subtracting. So when we're talking about the sum and difference of cubes, we're talking about problems that can involve either adding or subtracting. Okay, so sum or difference. Okay, we're not on both at the same time, but. And then when we're talking about cubes, we're talking about things called perfect cubes. Now, we had earlier spoken about perfect squares, and perfect squares are numbers like 1 squared, 2 squared, 3 squared, 4 squared, and so forth. So numbers like 1, 4, 9, 16, 25, these are things that we can take the square root of because they are perfect squares. Well, a perfect cube is something similar, except instead of squaring it, we would be cubing it. So examples of perfect cubes would be 1 to the third power, which is 1 times 1 times 1, or 1. 2 to the third power, which is 2 times 2 times 2, or 8. 3 to the third power, which is 3 times 3 times 3, or 27. We've got 4 to the third power, which is 4 times 4 times 4, which is 64. And we'll go up here to like 5 to the third power, which is 5 times 5 times 5, which is 125. Now, one thing you'll notice about perfect cubes is that they do get pretty big pretty fast. So unlike perfect squares, where we might easily know the first 10 or 11 of them, perfect cubes tend to get pretty big pretty fast. And so we don't see really big ones. Once you learn to recognize these ones, they will they're pretty much the only ones that show up. You might see some bigger ones somewhere. I mean, obviously there is a number that is 6 cubed or 7 cubed or 8 cubed and so forth, but you won't see those too often. So it's a pretty small collection of numbers. So when we're talking about the sum and difference of cubes, we are talking about adding or subtracting things that have these numbers in them, and we would also include things like x cubed or y cubed and so forth. All right, so I wanted to take a moment and differentiate between the sum and difference of cubes versus the difference of squares. So when we're talking about factoring, some special cases, when it's squares, we only consider the difference. When it's cubes, we can factor the sum or the difference. So that is an important distinction. So examples of the difference of squares would be something like x squared minus 9. Or 4x squared. There we go. Okay. 4x squared minus 25. And we would only factor the difference of squares. Now, if you have the sum of squares, there are ways to factor that, but they involve imaginary numbers. Okay, so we don't generally talk about that because we typically don't want to factor things that have imaginary numbers in them. Not that you can't do that or you can't approach it. It's just not usually where we go when we're talking about factoring. When you have the difference of squares, so something that takes the form a squared minus b squared, it factors into what are called conjugates, which is a plus b times a minus b. So for example, the x squared minus 9 could factor into x plus 3, x minus 3. Okay, and generally we'll do that using the formula and not using the area model. Sum and difference of cubes will of course involve sums and differences. So not just subtraction problems, but addition problems also. And so you might see something like x cubed plus 8 or 8x cubed minus 64. Okay, so you might see problems of that type. Maybe 27x to the third plus 125. We'll just keep getting a bunch of those numbers in there. Now, the factorization for that, we are going to factor it using a formula, but I'm not even going to show you what the formula is. We're just going to work on something called the SOAP sandwich. And so for factorization here, I am simply going to write SOAP sandwich, which is something that was kind of coined by one of the other Algebra 2 teachers here, the SOAP sandwich. All right, so hopefully you can kind of put those together. And I did put a difference of squares in the lesson somewhere, and I did put one on your homework as well, because we are covering in a reteach the difference of squares in this lesson. So if you had some trouble with it the first time or you were absent the day we had it, we're trying to go back and grab that information. Okay, so what on earth is this SOAP sandwich? It sounds disgusting. Some SOAP sandwich. Okay, well, first off, something to know is that the sum and difference of cubes will always, always, always factor into a binomial and a trinomial. So they are always going to factor. That's like so, I hate it when it's messy. Make it better. A binomial. There we go. Now my eye is hard to see. A binomial and a trinomial, meaning something with 2 terms and then something with 3 terms. So it's going to break it to 2 factors. You're going to have a algebraic expression with 2 terms in it times an algebraic expression with 3 terms in it. So we can always start by setting up the parentheses, and you'll have like a small parenthesis and then you'll have the bigger parenthesis. So you'll have the binomial here and you'll have the trinomial here. Okay. So that's how you can always start off. Now, SOAP is an acronym. So SOAP stands for this, okay? SOAP stands for same, opposite, always, positive. Okay, same, opposite, always, positive. And what that acronym is for is it tells us where we put plus signs and minus signs in our answer. So if the original problem was a sum, meaning it has a plus sign, then we will start our answer with the same sign, meaning it will start with a plus sign. And then the next operator will be the opposite. So it would be a minus sign. And then the last operator is always positive. You will always, always, always have a plus sign at the end. If the first or the original problem had a minus sign, then you start with the same or a minus sign. Then you'll have the opposite, which would be a plus sign. And of course, the end would be always positive. So SOAP stands for same, opposite, always, positive. And it is a way to remember where your plus and minus signs go. Sandwich is a way to remember the expression. So what's going to go in between the plus and the minus sign? So the way this kind of plays out in class is we'll go square it, smush it together like a sandwich, okay? And so you take what's in your binomial, you square it to get a slice of bread, square it to get a slice of bread, and then smush it together by multiplying in the middle. and you will get your trinomial. So the way that we are going to be factoring sum and difference of cubes this year is with the SOAP sandwich. Same, opposite, always positive. Square it, smush it together. Okay, so now that we've gone over that, which I'm sure is like super clear, let's go look at an example. Okay, so I think once you see a couple of these done out, it'll make more sense to you. So we've got here x cubed plus 8. So the first thing we want to see is that this is indeed the sum of cubes, because x to the third power is a perfect cube and 8 is a perfect cube. It is 2 cubed. Okay, and there's not a lot of perfect cube numbers that we see because they get big really fast. So the first thing we can do is set up our parentheses. I know that this is going to factor into a binomial times a trinomial. And then we will do SOAP. So remember, SOAP is same, opposite, always positive. Now what that means is this. When you look at the plus sign, that is not what I intended to have happen. I swear I can do better. There we go. That's what I wanted. Okay, so there's a plus sign there. And so when we go to place our pluses and minuses, we're going to do it like this. Same. So whatever that sign is, the sign in the binomial is the same sign. Then hopping over to the trinomial, the first operator will be the opposite, and the last operator is always positive. So same, opposite, always positive. Now if you're playing for partial credit, you have got some of your partial credit, which is always good news. Now we have to figure out what goes into the sandwich. So to fill in the binomial, we just ask ourselves, what to the third power gives us x cubed? That would be x. There we go. And then we do the other term. So what to the third power, or what cubed, gives us 8? That would be a 2. And then to get the trinomial, this is where we're going to make the sandwich. Square it, smush it together. So we're going to get the slices of bread by squaring the x and squaring the 2. Square it. So if we have one slice of bread is going to be x squared, the other slice of bread is going to be 2 squared, or 4. And then to get the filling for our sandwich, we are going to smush the x and the 2 together. So we're going to come back over here. We're going to square it, and then smush these two together right here to get the middle term of 2x, and we are done. So we have x plus 2 times x squared minus 2x plus 4. Ta-da! It is a one-line problem. You just need to learn how to use the SOAP sandwich. Okay, there is a formula for this. So, and you can look up the formula, and I'm going to mention the formula in a little bit because we're going to look at some other ways that you could do this problem. But there we go. So let's look at one that has the leading coefficient in it, because I think this is worth exploring. So 27 and 64 are also perfect squares. So we know that we can factor this using the SOAP sandwich. First step is we'll set up our parentheses. So we'll set up our binomial and our trinomial, and then remember the acronym SOAP, same, opposite, always positive. So in this particular problem, since we started with a minus sign, then we'll use the same sign in the first set of parentheses, and then the next operator will be the opposite, and then always positive. So same, opposite, always positive. That is the SOAP part of the SOAP sandwich. Now to fill in our parentheses here, we want to ask ourselves what to the third power gives us. So in this case, what to the third power gives us 27? Well, that would be a 3. What to the third power gives us x to the third power? Don't overthink it. It's an x. And what to the third power gives us 64, and that's going to be on the other side of the minus sign. Okay, now we want to be a little bit careful. So we're going to fill in the sandwich. We're going to square it, smush it together. Okay, square it, smush it together. Now just take care. For the left-hand side, we're going to take the 3x and we're going to square it, which means we're going to multiply it by itself, which means we are going to get 9x squared. 3x times 3x is going to give us 9x squared. Down on the other end, we're going to take the 4 and square it. And some people have been like, well, what if it's like a -4? Like, we took care of the pluses and the minuses with the SOAP. Okay, so we can just take the 4, square it, and that's going to become 16. Square it, smush it together. So for the middle part, we want to do 3x times 4, which would be 12x. And then we're done. So 3x minus 4 times 9x squared plus 12x plus 16. So square it. Now, because this is on a video, and one of the advantages of a video is that you can go back, you can rewind the problem, you can go listen to the explanation again if you realize that you tuned out, or you got a text message, I don't know. Or you're just like, yeah, I don't know where she got that 12x from, or where did the 9 come from, or and you just want to hear it, just back it up for 2.5 minutes and just rewind that 2.5 minutes and get the explanation again. Where's my little mouse? There it is. So the next ones are practice. So I want you to practice, and you'll notice that even though those problems look similar on the outset, that they are actually different problems. So if you're doing this from home, pause the video, try to factor these on your own, okay? And then unpause the video and we will check them together. Okay, so the first one is the difference of cubes, because 64 is 4 to the third power. So we have the difference of cubes. So we'll set up our binomial and our trinomial, and then we will engage SOAP. Same, opposite, always positive. So since this was a subtraction problem, we will start off with a minus. Minus, and same, then opposite, whatever the opposite is, and then always positive. And we ask ourselves, what to the third power gives us x cubed? That would be x. And what to the third power gives us 64? That is 4. And now to get the sandwich, we're going to square it, smush it together. So to get the left-hand slice of bread, we're going to square the x. To get the right-hand slice of bread, we're going to square this 4 and get 16. And then we're going to multiply them together, x times 4, which will give us 4x. Now, the problem on the right is the difference of squares, and it is the x squared that gives you the tip off there, because 64 is also equal to 8 squared. And so 64, like the number 1, is a number that is both a perfect square and also a perfect cube. And perfect squares, or the difference of squares, will factor into conjugates. And so we will have x plus 8, x minus 8. Okay, so I put that in there to call your attention to the fact that it is possible that numbers could be a perfect square and also a perfect cube. There's not a lot, but and just to really draw out the difference there and make sure you're paying attention. Like I said, I did put one of those on your homework as well, so don't be thrown off or surprised when you're going through the factoring problems. You're like, soap sandwich, soap sandwich, soap sandwich. Oh no, difference of squares. Okay. So pay attention when you're taking, when you're taking like your high stakes tests and stuff. Obviously, people can scramble these problems up any way they want, and beyond algebra 2, you might just be in a situation where you need to factor, and so then you need to be the one that recognizes what kind of a factoring problem you're looking at. So stay on your toes. Now, I don't like to just teach like little tricks for factoring, although typically sum and difference of cubes is typically taught with a formula without a lot of justification for the formula. You are welcome to go onto the information superhighway where you are locating this video probably, and look for proofs of the formulas for factoring the sum and difference of cubes. Knock yourselves out. Let me know if you find anything good. Okay, but I didn't want to just do this and not address like how do we know this is true, or how can we be sure that this works. So on the left, we're going to go ahead and factor 8x to the third plus 1. So this is a sum of cubes. So we have our binomial times our trinomial, and we're going to do same, opposite, always positive. What to the third power gives me 8? That would be 2. And what to the third power gives me x to the third? That would be x. What to the third power gives me 1? That would be 1. And then for our sandwich, we're going to square it, smush it together. So we want 2x squared. So that is 2x times 2x, which will give us 4x squared. And then the other slice of the bread will be 1 squared, or just 1. And then the bread, or the filling, okay, our PBJ is going to be 2x times 1. Smush it together. 2x times 1 is just 2x. So I want to show you this. Remember where I've said what's the opposite of multiplication? And there are 2 answers that would be equally correct to that question. You could say division is the opposite of multiplication, or you could say factoring is the opposite of multiplication. And their division and factoring are really, really closely related, which you can see with that area model, that a factoring problem and a division problem on the area model look very similar. And so if I want to know if I have factored correctly, one of the things I can do is I can check it by doing the multiplication. So I'm going to come over here and set up my multiplication. So 2x times 4x squared is 8x to the third. 2x times negative 2x is negative 4x squared. 2x times 1 is 2x. And then my next line down, 4x squared times 1 is 4x squared. Negative 2x times 1 is negative 2x, and 1 times 1 is 1. And what you'll notice is that 4x squared and negative 4x squared cancel each other out when you add them. And when you add the negative 2x and the 2x, those will also cancel each other out. And so you will be left with 8x to the third minus 1, plus 1, which is what we originally started with. And so you can check your answer that way. Incidentally, you can also do a multiple choice question by simply multiplying together the answer choices. A great thing, though, on multiple choice questions, though, is to use the SOAP, because if you're looking at the answer choices and it doesn't follow the same opposite, always positive, then you can definitely eliminate those as things that you want to guess, which can come in really handy if you're running out of time or you blank out on like the rest of it and so forth, okay? Now, there are some other ways that you can see this taught. So on the left, I have what Photomath does. Now, Photomath is doing it the same way we are, but you'll notice that they do these notation changes. So they take the 8x to the third and they change it to 2 to the third times x to the third. And then they change the notation again and say that that is 2x all to the third power. And what they're doing in that step, they take the 1 and they change the 1 to 1 to the third power. So what they're doing in here is rewriting it as a to the third plus b to the third. So they're writing it in a way that makes it explicitly the sum of cubes. And then you'll notice in this step, this is actually a direct application of the formula, where they're writing a plus b, and then they have a squared minus ab plus b squared. And if I had given you the formula, this is almost what I would have looked like. It would have had a plus minus in it. So we could do both sum and difference in one line. But that's what they're doing. So the first couple of steps is just rewriting it in this form where you can see what the A and the B are. And then that third step is this using of the formula. The way I presented it in this video, you should be able to go straight to the solution with no work. So if I start seeing these steps from you, whoops. Yeah, like I'm gonna block it out. Don't do it, kids. Don't do it. Steps like that. What I am going to suspect is that you didn't really watch this video and that you are just copying off of Photomath, because really those are extra steps that don't need to be done. About 3 years ago, it was the year we had all the desk shields in our classrooms. I don't know where they found it, but I had some students find the most complicated, convoluted way to factor the sum and difference of cubes that involved about 7 or 8 lines worth of work that I had to run by several other math teachers, and we had to really stare at it so we could figure out what was going on. It worked, but none of us had ever seen it, and we all thought, well, why? um because in this video I have showed you a way to do this to get to the answer in one step, and we verified it with multiplication. You are welcome to multiply all of them. You can multiply all of them together if you really want. Um, but yeah, like, just don't, okay? Don't, if you're doing 7 or 8 lines of work, I don't want to look at it, and you also probably don't know what it is. So just don't, okay? Now, division. I taught division last year, and the reasoning behind it was I really wanted to reinforce how that division process worked, so that you could see how the division worked, and also it taps into the idea of roots versus factors, which is an important algebra concept. And so it really got at this a different way. What I will do is I will post a link to that video in the OneNote notebook if you would like to check it out. I think it's an interesting way to do it. There was obviously a reason why I thought that was a great idea last year. And the reason why I decided to switch back to the soap sandwich was mostly efficiency. So I think we can get to where we need to go faster. And I'm not sure that the division review and the other skills gave the payoff that I wanted them to. But I will post a video to that. And if you are interested in maybe some extra credit for demonstrating like a problem doing it by using division, then I would be super open to that. Just let me know, like, what would I have to do, Miss Taylor? What would you want to see? Just because I watched the video and I'll show you that I can do it that way. Anyway, so there might be some other ways to do this as well. Generally, though, like, this is a skill that's taught with the formula, kind of like the quadratic formula, and I present it using the SOAP sandwich, which I think is a lot easier to get your head around and get to, from the problem to the solution or answer, yeah, the way we want to go. So your classwork homework, we've got 5 factoring problems. Okay, notice whether there's sums or differences, and keep on the lookout for that difference of squares. This my head is covering that, so that's fantastic. Hang on, I can actually tell you what that is. You're welcome to go look, but I still have it somewhere, because I went and checked the answer for it before I finalized the homework. Okay, then 6 through 10 are review materials. So number 6 is a division problem. So go and practice the division on that. Incidentally, number 6, for people who don't use the area model, number 6 would be a very, very difficult problem, but with the area model, it is not any harder than anything else. Question 7 is x plus 4 a factor of that cubic, and how do you know? Which is the critical question, because that is a yes/no question. So yes, it is a factor. I know it is a factor because, or no, it is not a factor because. And then question 8, which maybe you can't see, if y equals x to the 4th is the parent function, what are the transformations on? And then the other one that you can't see because it's like behind my head there is y equals my phone just went to bed. There it goes. X minus 3 all to the 4th plus 2. Okay. And what I'm getting at in that question is like one of those things that's sort of new and sort of review. We have not done something that was x to the 4th, but we know that math is consistent. So if you don't remember the transformations, go and graph it and see if by graphing it, you're able to answer the question and get that refresher in on the transformations. Question 9 is a quadratic to solve, and I'm going to specify is any non-cheating strategy. So you may not photomath it and just copy down the answers, and you may not copy the answers off your best friend. Okay, but You may solve it using any of the other strategies that we have covered in class. And then question 10, is 3 negative 2 a solution to y is less than 2x plus 1? So that's a yes, no question, but it should come with some sort of work or explanation. All right, so that's it for this lesson. Thank you for joining us today. The cat that was over here is now across the room staring at me. I think he's hungry. He's hungry, or he wants his Prozac. He might just want his Prozac. I don't know. So we'll go take care of him. You guys are going to do your work. And as always, you know where to find me.